Hi everyone, my name is again to a new YouTube video, and in this time we will talk about a subsequent feature that we were doing the previous videos as well, and the name of this feature is BGP Unequal Cost Load Balancing, right? If you go through my channel, the last two videos we were talking about additional path, how additional path helps out to bring visibility in the network, and how it support the improvement and achievement of hot potato routing as well, to choose the shortest path to reach out the core or the particular prefix destination, right? So that was the goal of additional path and bring visibility and so on. But additional path didn't improve the convergence totally, right? Because still in the RIP, FIP or CEF, well, FIP and CEF, RIP is control plane, still we needed to have a backup route there installed to improve the convergence in case of the best path goes down. And we explained this in the previous video, right? That's why we were using BGP peak H, right? That BGP peak H is not more than having a backup path into the FIP and CEF and have it installed into that table. So now we will look into a very interesting feature, which is unequal cost load balancing. Basically, the goal is the same, right? With those redundant mechanisms like BGP peak H or even multipathing, the goal is to have another path installed into the FIP or CEF, right? And this, in fact, improve the convergence times. In the particular case of unequal cost load balancing, we will have not only a backup path or a path installed into the FIP or CEF, I mean the path will be there, but also the traffic will be balanced across different paths for reaching our particular destination. So basically it's the same concept as multipath, basically it's multipath, but it doesn't count that the metric to reach out to that particular prefix over those two paths should be the same. One path to reach out that particular prefix can be different than the other, can be higher or lower, and even though that they are different, we are doing unequal cost load balancing, right? And how this is working, okay? So let's go through the whiteboard, right? How BGP peak and BGP multipath with unequal load balancing works, right? So basically, let's say that I have a network, just to put it something simple. Let's say I have these four routers here, and this is ASBR1, and this is ASBR2, right? Let's say I have this router and here I have internet connection. So similar as my mock lab. Actually, I forgot to copy paste here in the whiteboard, right? So we have two paths to reach out a particular destination. Let's put that is 8888, okay? So let's imagine that here we have a route reflector as well, and this is a P1. So the ASBR1 forward the prefix that they receive from INET. We will imagine that we have a BGP sessions between INET and ASBR, and BGP sessions between ASBRs and reflector to the P1, similar as our MOCLAB one, right? So we forward the prefix to reflector 1. Now, reflector propagate the prefix to the P. So P, for reach out particular destination X, well, we'll suppose that 8888 is the prefix X. So then it sees, P1 sees two paths, one through ASBR1 and the other through ASBR2. This is, P1 see two paths because we probably configure additional path, right? And that's how all those features, correlate and work together in an harmony, because if we don't have one, probably we will miss or we will not be able to use the other one. So they are working in harmony together. Now, for prefix X, I have the possibility to reach through ASBR1 or through ASBR2. And obviously, if we don't modify anything in the BGP attributes of those router when they advertise to route reflector, BGP has the best path algorithm, right? And this is basically the way that BGP choose the best prefix. IGP protocols has different ways to choose. For example, in the case of OSPF and ISIS as well, is the lowest metric, the lowest cost, right, to reach out a particular prefix. So the way that they choose a path to reach out a particular destination is quite different compared to BGP, right? BGP is a very complex protocol, so that's why it uses a much more sophisticated algorithm to choose the best path, right? And then here we have the weight, we have local preference, we have, I will not mention all of them, but just to lead it out, ASPAT, for example, we have the MET, probably here we have origin code as well in the middle, right? We have MET, and then after that we have EVGP over IVGP, and then in some last stage before doing load balancing, we have metric to reach out the next hop, or this is more or less the metric, IGP metric, right? More or less. So this is the cost to reach out the particular destination, right? So for example, if wait, local preference, probably here I forgot to put originated local routes as well. Then we have ASPAT, origin code, MET, EVGP over IVGP, and then the metric to reach out the particular next hop. The lowest is the preferred one. In this side is where we can do load balancing, right? If the metric to reach out the particular paths are the same, we can do multipathing, right? Equal cost multipathing. So multipathing equal cost. For example, P1, let's say that in our example, right? Let's imagine ASBR1, ASBR2 propagate the route to route reflector propagate to the P1. Let's say that they didn't change anything in the weight, in the local preference, in the ASPAT, origin code, MET, EVGP over IVGP. Both of them are IVGP. So this is our internal network, right? So both of them advertise the route. So both of them advertise over IVGP. So P1 do the best path selection over those two paths, ASBR1 and ASBR2. P1 sees that everything is the same, ASPAT didn't change, MET didn't change, both of them are IVGP. Then the metric to reach out each of them, right? So then P1, let's imagine that this links has a cost of 10, 10, 10. So P1, again, I'm sorry if I'm repeating too much this, but I want this to be clear, right? So P1 basically see that the weight is similar from ASBR1 and ASBR2. Weight is similar, local preference is similar, originated routes, this doesn't apply, but it goes through the next one, ASPAT. So both of them advertise the same, ASPAT over INET, so it's similar as well. Then we have MET. If they don't change, the MET as well is similar. And then we have EVGP over IVGP. Both of them are IVGP neighbors, so it's similar. And then it's the metric, right? The metric to reach out ASBR1 or ASBR2. So the metric in this topology is similar, right? We have 10, 20, 10, 20. So metric is the same, meaning we can do multipathing, equal cost multipathing. But what happens if this metric changed to 20, right? Then we have only one path over ASBR1 because the metric is lower. It has 20 of metric. And in the bottom path, we have 30. So then it's not same cost, right? And that's where this feature, BGP multipath unequal cost load balancing, take into place. Whenever we have different metric, IGP metric, to reach out the particular next hops. So in this case, we have different metrics. And in this case, we could, if we want to use both of them, ASBR1 and ASBR2, we couldn't do multipathing with equal cost because they are different cost, but we can use unequal cost load balancing feature. And with that, we can balance the traffic unequally, of course, because we have lower cost over one path and higher over other. So we can balance the path unequal way over those two paths. But anyways, the traffic will be propagated in both of them, right? So it means that we will have some kind of load balancing, okay? So that's what we will do in our lab, right? And that's what I want to show you in the lab as well. So here we have our EVNG topology, right? So we are now in P1, and then we have ASBR1 and ASBR2 as a next hop. So I modify the cost, right, for the ASBR2 to be the less preferred path. So normally the ISIS metric, all of them, or the links are in 10. So with if I change the metric to reach out the ASBR2, for example, from P1 to P2, P1 and P2 in the link over that is connected to the ASBR2, if I change the metric from 10 to 100, then P1 will prefer the metric of the IGP of the ASBR1, right? an ASBR2 will have the lower preference because the metric, the IGP metric, will be higher, right? So that's what I did. I changed the metric in P1 and P2 towards ASBR2, to ASBR2 to be the less preferred path, and ASBR1 to be the most preferred path, but both of them advertise the prefix 8888 to PE1, right? And we are using the same prefix test that we were using in the previous video, and we will focus on that as well, right? So it will be clearly seen, and we will go through the CLI actually. So for example, if we go to P1, let's say, and we check show BGP VPN before route extinguisher 100, then we see the prefix 8888 and we receive over ASBR2 and ASBR1, right? So if we do a closer look into that, 8888, remember show BGP VPN before unicast is the control plane of BGP. So here we see that the metric to reach out ASBR1 is 20 because we are using the lower cost path, right? Now, the metric to reach out the ASBR2 is 110 because I increased the metric, right? So technically here, obviously ASBR1 is the preferred path. So you see here is the best path because it has the lower metric. All the other upper attributes are the same, but just we have a better metric of the IGP. That's why we choose ASBR1. But in our case, we want to load balance the traffic unequally. You know, here the cost is unequal and we want to load balance between them, right? So if we do in P1 show route BRF green 8888, we only see one path, which is ASBR1. I don't want to see one path, I want to see two paths. So then I need to enable BGP maximum path unequal cost load balancing. And how I do that? Show a router BGP, then BRF green, address family PV4, and here maximum path, IBGP, I want a two paths only, and then here unequal cost load balancing. I will explain and I will do another video why and where we can use EIVGP and EVGP. Those are and has different behavior, especially if we use different address families as well. So it's very important for us to know how they work. But for now, we will just enable unequal cost load balancing for the IBGP prefixes, right? So then we show configuration, commit. Now, I want to show you what we can see now in BGP, right? Now, if you see here, we still see the best path over the ASBR1. Now let me just do show route BRF green. Now we see both paths, right? We see ASBR1 and ASBR2, and there is multipath keyword there. So meaning that the traffic is being load balanced, not unequally, because the metric are different, right? But still, we have some traffic going over ASBR1 and some other traffic goes over ASBR2. Now if you do show Ceph BRS green, 8888, then we see that there are two paths as well installed into the FIP, right? When we type show route, we are looking into the RIP. When we type show Ceph, we are looking into the line card level. So there you see what are the next hops. You see some other specific values that represent more the hardware part of the line card. But the most important is that we see that the path is being load balanced. There is BGP multipath in there. Now, if we go through the BGP, show BGP for unicast, well, here we don't have the M, because normally when we'll do multipathing, we have the M. I believe that's because we are not doing equal cost load balancing. But anyways, in the hardware level, from the Ceph perspective, we are doing multipathing using unequal cost. This feature is quite useful if you want to load balance the traffic. In some requirements you would like to load balance the traffic, in some of them not, depending on the service. But this is how the feature works, and it's very useful if you want to load balance the traffic and you don't have equal cost. Yeah, and it works for all the AFIs that you want to configure. So in my case, for example, I configure it as I show you under the BRF green, and I went under the BRF green, and then I configure maximum path IBGP to unequal cost, right? And that's it. That's another feature of BGP, another interesting knobs that we can know around that. Next video we'll probably talk about BGP core, multipathing as well, equal cost. We'll probably see the difference, other keywords that we see there. And I am not forgetting about Ostinato. I'm just doing more testing, and we will have a video about it as well. And thank you for my friend Sribash that he shared that with me, and happily me to test it out that. So that's all for the video today, and I hope that you have learned something, and see you in the next one.